Good evening, everybody. Welcome back to another session of data science training from 360DigiTMG. And yesterday we were starting a new topic. We had started a new topic, which was forecasting working with time series data. And in continuation to that, we'll be studying a little more about that. So I was just opening the presentation. So a quick recap. We have discussed about the differences between time series and cross-sectional data, and we saw that the time series data is having a time component to it, and cross-sectional is something that is, in theory, can be taken in one shot. So that is what is the difference. And then we have an example. The most important aspect of time series is that it is just one column of information. That is the Y, and that is what we are trying to predict as well. So this really makes life a lot simple. All right. Then the most important aspect of working with the time series data is the time index. All right. So we discussed about the time index rather than looking at it in the perspective of the time component. All right. So it can be monthly data, yearly data, data by the minute, data by the hour. It doesn't matter as long as the periodicity of the data is the same. If you're having monthly, you continue to have monthly. If you're having yearly, you continue to have yearly. All right. So that is something we discussed. And obviously, whenever we do any forecasting, we are going to have errors. And we'll see about the errors in a moment. What are the steps? Of course, there's no point in reviewing this at this point of time because we really cannot remember what is what. So going ahead, now let us look into the components, do a recap with reference to the components of the time series data. So there are 4 components: level, trends, and seasonality or seasonal patterns. And then we have the non-seasonal component, which is the noise. All right. So these are some of the things that we have seen. And what is level? It is something that is non-visual. All right. Level is something that is non-visual because it is a single value, and any data will definitely have a level. All right. You cannot have data without level. However, you may have data without trend or seasonality or noise. All right. So that is possible. So we have seen about the concept of trend, approximately 3 years. But again, these definitions are very fluid in the current scenario. Now we discussed about the COVID, right? Is it on? Can we not use the expression it is on the upward trend? Should we only use it only after it is there for 3 years? All right, we cannot do that. So yeah, you'll have to use a little bit of your own judgment in the expressions. Seasonal, of course, is within 1 year. So you have it within 7 days. All right, you can have this entire seasonality repeating in a 24-hour period. You can have the seasonality happening in the, the 1 month, or you can have it in a year, whatever it is possible, you can have that. Now, can you think of a case where seasonality is more than 1 year? Can you give me a case where seasonality is more than 1 year? I want you to think about it. In the Indian context, you'll be able to understand the example. Private messages, please. Yeah, private messages, please. Very good. Excellent. More than 1 year. Vegetable market is more than 1 year, is it? You have it in October in 2019, then you will have it in July in 2022, is it? One example has been given. Excellent. Very nice. I'm hoping other people also give the example. Is it seasonal? Does it happen every X number of years? Okay, let me give the example. World Cup football, World Cup cricket, every 4 years. Presidential elections, currently in the US. The Kumbh Mela, every 12 years. Is it making sense? No, no. Sales of raincoats happen in rainy season, that is within 1 year. My question to you is scenarios where it goes beyond a year. Do you understand, friends? Supermarket, sales of raincoats, all that is seasonal. Seasonal in the normal sense, which happens within a year. But I'm talking about, so there is going to be a huge crowd for people traveling to Olympics. All right, the country which is hosting the Olympics, 2 years before that, they will start planning for the influx. All right, huge number of people are going to come. Is it clear? One of the biggest failures was of Olympics in the recent past was the Rio Olympics. All right, totally mismanaged, and the guests or basically the tourists had a very bad time. Gate exams are happening more than 1 year. 1 year, is it? Every alternate year or something? Is it? I don't know. I don't know about gate exams. Do the gate exams happen with a periodicity of more than 1 year? Yeah, then why are you saying gate exams? All right. So these are some rare scenarios wherein you have more than 1 year, but generally the seasonality is considered to be within 1 year. All right. These are something that happens. There are a lot of these kind of cases, but yeah, we don't generally talk about that. So while I did say that seasonality is within 1 year, in certain cases it can go beyond that also. That was the point I was trying to make. So this is the seasonality. It happens within 1 year. And then noise, of course. Now again, do we call whatever is happening because of the COVID pandemic noise or not noise? Or is it become a routine? All right. What do we call that? So anyway, these are some questions. And then we discussed about the visualization of the time series data in the perspective of what is called as the time plot. All right. So this is the time plot, and we talked about no trend, no seasonality, trend and seasonality, trend and seasonality being multiplicative, so on and so forth. All right. And Subsequently, what a time plot is, this is what a time plot is. Time plot plots a variable against the time index, appropriate for visualizing serially collected data or time series data, brings out many useful aspects of the structure of data. Example, electrical usage, we have seen this. And then we also established that the concept of length of seasonality. Now, how many of you remember how to represent the length of seasonality? What is the method of representing length of seasonality? I mentioned it in yesterday's class. The length of seasonality is represented by the alphabet M. Remember? Are you remembering? Why are you confusing with hazard and all that now? Somebody mentioned hazard. Don't confuse with all those things. Is it clear? Do you remember the capital M? Yesterday I mentioned, right? In this particular data, what is the length of seasonality? What is the M value here? What is the M value here? 4. We say 4. We don't say 4 quarters or 1 year and all that. We say the length of seasonality is 4. All right. Then of course we then of course we excuse me. Excuse me. Something is stuck in my throat. 1 minute. All right. So here we have seen the data, which definitely the trend is quite clearly visible. All right. Whether it is there or not is. I mean, in the previous case, whether it is there or not was a little difficult to ascertain. But in this particular case, we can definitely be sure that the trend is very much there. And of course, we are also able to identify the noise. All right. Now, this is one of the most popular visualizations. All right. This is one of the most popular visualizations called the time plot. We also have another plot which is called the lag plot. Now, for this, I'm going to be referring back to certain classes that you have attended long back. All right. Now, in the lag, before I get into the lag plot, how many of you remember the line conditions for linear regression? If I were to take a quiz now, if I were to take an interview, would you be able to answer it? The line conditions for, the line conditions. Okay, fine. Please tell me the assumptions with reference to errors. What are the assumptions with reference to errors in the line conditions? Line conditions which we have discussed as part of the multiple linear regression. Nobody remembers? Nobody wants to respond? Very sad. So the line requirements, as far as the errors were concerned, were In fact, I had also given you a homework at that point of time. IID, identically and independently distributed normal. All right. Then there should be homoscedasticity, zero mean, and what else? There should not be autocorrelation. At least, do you remember this? Do you remember whatever I have just mentioned? There should not be any autocorrelation. Right? There should not be any autocorrelation, zero mean, homoscedasticity. If it is not homoscedasticity, it is called heteroscedasticity, IID normal. Right? Now, when we were discussing about the autocorrelation, what did I tell you? Error 1 has a relation with error 2, error 2 has a relation with error 3, error 3 has a relation with error 4, so on and so forth. Or error 1, there's a reason why I'm not actually using my pen, because I want you to probably close your eyes and try to visualize this particular topic when we have done. I also mentioned I had written down the errors in the horizontal and in the vertical format, E1, E2, E3 in the vertical format. So error 1 and is having a relation with error 3, error 2 with error 4, error 3 with error 5, error 4 with error 6, error 5 with error 7. All right, error 6 with error 8, so on and so forth. Or skip of 3, error 1 with error 4, error 2 with error 5, so on and so forth. If such a situation is there, then we have a autocorrelation. Do you all remember this? Are you able to recollect this? It is very easy to simply say yes. Whether you recollect or don't recollect, you can definitely say yes. What is the big deal? Hmm? All right. Now, we did not get into the detailed discussion of what autocorrelation is at that point of time, but now we are going to be discussing about that autocorrelation. So there was a reason why I wanted you to, revisit in your memory about that error and that autocorrelation, what is that expression and all that, because I am going to be talking about something what is known as the lag plot. All right. So plots a variable against its own lag sample, brings out possible association between successive samples. All right. Monthly sale of DVDs by a music store in a year. Now, obviously, this is an ancient data. Nobody buys DVDs, but nevertheless. Now, on one axis, we have the DVDs sold in time period T, and the other axis, I have DVDs sold in K less time period, or probably we have them in the lag values. Okay. So let us just look at this particular data. Now, before I go into that data, let me just hide something. All right. All right. Now let us look at this. I have hidden the remaining values. There's a reason for it. I'll show it in a moment. Right. Now this is the data that I have. All right. This is the data that I have to measure I need to find out if there exists a relationship between 123 and 130, 130 and 125, 125 and 138, 138 and 145, so on and so forth. All right. I want to measure if there exists a relationship like this. Now, to be able to to find out about the relationship like this, what we are doing is I will make this 123 sit here. I'll make this 130 sit here. I'll make this 125 sit here. I'll make this 138 sit here. All right. So what I'm going to do is here you go. Yeah. All right. Now, if there is a relationship, if I were to look at the correlation between these two columns, which is essentially the same column with itself. If I look at the correlation between these two columns, which is essentially the data with itself, I am in fact looking at autocorrelation. Do you understand the concept of autocorrelation? There, when we were discussing about the errors, we were talking about the autocorrelation of errors. Excuse me. Is it clear? Now, you may have the autocorrelation with lag 1 or lag 2. What is lag 2? I already discussed with you. So on and so forth. Is it clear? So if any of the lags, whether it is lag 1 or lag 2 or lag 3 or lag 4 or lag 5, whatever, if any of the lags, all right, if any of the lags has a good correlation, then there exists an autocorrelation. All right, there exists an autocorrelation. Okay. Now, when I plot this data, so I call this YT versus YT minus 1. YT minus 1 is nothing but lag 1. So the original data with its own lagged, when I plot it, then I get what is called as a lag plot. All right. And if the lag plot is having good correlation, good tightness, then I can conclude that we are going to progressively, all right, we are going to progressively improve. We can, the next value, next value, next value can be automatically forecasted. Okay. So this is what it is. Now, we can either plot the lag plot for lag 1, lag 2, lag 3, lag 4, lag 5, like that. We can continuously plot and then compare for, okay, how much is lag 1 looking like, and then look at the correlation coefficients of each. Or we can take the correlation coefficients of all possible lags, starting from 1 all the way to 10, 12, 13, depending on how many you want. So what is the correlation of the original with lag 1? Record it. What is the correlation of original with lag 2? Record it. Correlation of original with lag 3? Record it. So on and so forth. Now, when you complete this entire data of the correlation coefficients, you can create a plot which is called ACF plot or autocorrelation function plot. All right, autocorrelation function plot, which will plot for the correlation coefficient for the kth lag. All right, for the kth lag. And whenever we plot anything, any data, we all know about the confidence interval. You remember the confidence interval, right? So for any value, any measurement, so for the lag one, if I have some confidence I'm sorry, for some um, correlation coefficient value, then for that lag one, what is the confidence interval? Similarly, for lag 2, if I have some coefficient of correlation, then for that, what is the confidence interval? Like that, when I plot it, this is what it looks like. All right. So the red dotted line on both sides is the confidence interval. 95% is the standard confidence interval that we are dealing with. All right, 95% is the standard confidence interval that we are dealing with. This is what we have. All right, and let us try and understand about that blue line. That blue line is indication of how much correlation coefficient exists between the data and the lag. Now this is the autocorrelation function or the ACF plot for the VCR sales. So lag 1, the correlation coefficient is little less than 0.6. Lag 2, it is about 0.4, and lag 3 is less than or about 0.1. Is it clear? Lag 1, lag 2, lag 3. Is it clear so far? Perfect. All right. Now, I'm going to give you some more information about this ACF plot. If you look at this plot, none of the lags are significant, meaning none of the lags are usable. All right, none of the lags are usable. Why? Because the blue line has not gone beyond the red dotted line. All right, the blue line has not gone beyond the red dotted line. Therefore, it is not possible. Why? Give me a moment. I'll explain in a moment. Now, whenever we have a confidence interval, all right, how does that interval look like? The confidence interval is something like this. Is it making sense? To make this like this, then this entire zone is 95%. I hope that part is clear. This entire zone is 95%, which means that what is beyond this line, all right, what is beyond this line, this zone much 0.025 and this is 0.025. Now, when I look at this particular value, left extreme, and in the concept of the p-value, this area, all right, area is greater than 0.05. Is it making sense? Imagine for a moment it is here. This is the point at 0.8. Now, when you draw the let me try it once again, otherwise I'll leave it at that. When I try it like this, then this area is less than 0.025.
Hello participants, presenter is facing some technical issue. He is gonna join very soon.
Some network issue. Yeah, can you hear me? Can you see the screen? Okay, sorry. Surprisingly, I don't know what is happening. My connected speed is pretty good, but I don't know what happened. I mean, it's pretty nice, even for Hyderabad standards. It's a pretty good connection that I have, but I really don't know what happened. Let me also check the upload. Upload also is pretty good. Yeah. Anyway, something happened. Let us ignore that. Let me start the recording again. So we were discussing about the p-value with reference to this. So if this point had been here, then it corresponds to a p-value less than alpha or less than 0.05. So when you have p low, null go, reject null hypothesis, take action. So what is the action? Can I use the lag 1? Can I use the lag 1 for forecasting? Can I use the lag 1 for forecasting? Yes, I can. Is it clear? Yes, I can. In the current scenario, can I use the lag 1 for forecasting? No, I can't. Is it clear? Right. So that is the reason why we have all this. All right. So this is the second scenario where we had, talked about the electricity usage for Washington water and power. All right. So there we had this. Now, if you notice this very carefully, here it's practically zero. Here it is actually zero, close to zero, close to zero, close to zero, actually zero. So every alternate lag is having very less or practically zero correlation, and the even lags is having high correlation. Is it clear? Now I would advise you to look at this particular data. All right, not the data, sorry, look at the time plot which you have seen in a few slides before, and look at the ACF plots and try to figure out the relationship, why we are getting this. All right, why we are getting this, try to figure it out. All right. Okay, so these are the two main visualizations, the time plot and the ACF plot. We rarely, or for all practical purposes, we don't do the lag plot, we only do the ACF plot. So at the end of the EDA, the questions that we ask in the plots are, is there a trend? Is there seasonality in the data? Is there something that is random in the data? All right, this is something that we try to look at. What about level? Why don't we look for level when we are doing the EDA? Can you please respond? Is it, please respond why we are not talking about level? Very good. Level is something that is always there. All right, level is something that is always there. And also in the exploratory analysis that we are doing, this is more of a visual exploratory analysis that we are doing. And level is something that we cannot see in the time series. However, in one particular scenario, it is possible to know the level. What scenario can you visualize the level? Please tell me. In what scenario, in what plot will you be able to visualize the level? Maybe I'll show you the slide where I expect you to figure it out. Yeah, please look at this. And can you tell me in what scenario you can figure out the level? Okay, the answer I'll give it to you. In the scenario where you can find out the level in the visualization is only when the trend does not exist. All right. So if you put a horizontal line through the data which has no trend, that becomes your level. I'm talking about visualizing the level. I'm not saying level is there or not. Yes, it is there. Is it clear? So in the top three, the first row or the top three visualizations, we can say that line is the level line. Is it clear? All right. But again, that is a very rare scenario. So we have seen that. Now, once we have gotten the data, we need to partition it. Obviously, right? We need to partition the data into train and test. Okay. So the partitioning of the data, we call it validation or testing or whatever, kind of not important. Okay. Now, how do you partition the data? We have seen various methods of partition, right? We have seen methods of partition wherein we do the partition in order, then we partition in random. All right. So can you please tell me the advantages, disadvantages of partitioning in random, partitioning uh, uh, in order, in series? What will be the advantage and disadvantage for this? Can you please tell me? The time series data, please remember, the time series data cannot be partitioned. All right. The time series data cannot be partitioned randomly. It has to be partitioned only serially, because the essence of the data is in the order. All right. The essence of the data, what does the data trying to tell you, is in the order. If you are going to jumble up the order, it is nothing but some random numbers. Do you understand, friends? So we never partition the data randomly. We always partition data serially, and this is how we partition. So the initial few values or the oldest values are training data, and the newest values are the validation or test data. All right, this is what it is. And of course, what we are going to be predicting after the data. So the assumption here is that you are having data from Jan 1991 to May 2004. Assume or April 2004, or I don't know, that line is not on May. So maybe April 2004 or whatever. Anyway, we have the data. I'll be showing the data in some time. So the assumption is that we are today, let us say if it is April or March or whatever, let us say the data is till March 2004. So today we are on April 1st, 2004. And for April 2004, May 2004, we have no information whatsoever, and that is why we are forecasting. That is the assumption. Is it clear? So now, how to choose the period for validation or testing? All right. It will depend on the horizon of the forecast. Now, what is forecast horizon? Whatever you are mentioned there as future, how much into the future you want to do the forecast? You want 6 months data. I have monthly data for the last 22 months. All right, I have monthly data for the last 22 months. Can you please tell me my forecast for the next 3 months? Yes, I can tell you. So basis of the forecast of 3 months expectation, I will choose my period of validation to maybe 3 months or 6 months or some multiple of that particular value. Is it clear? So that is one method of choosing the forecast horizon. The other one is on the basis of seasonality. All right, on the basis of seasonality. What is the length of one complete seasonality? All right, what is the length of one complete seasonality? Meaning, if my data is having m is equal to 4, the way which we had seen about the Washington water and power or the ice cream data, if the length of seasonality is equal to 4, then I must have 4 as the validation period or multiples of the complete seasonality. All right. Again, it will depend on the length of the series. If you have a very long series data, some 200 values are there. Even if the some 200 or 250 months data you have, let us say, all right, 250 months data you are having, and you one complete seasonality is 12. Then it doesn't make sense to only have 12 and 200 records there. You may probably want to have 20, 25, 30, even 50, 60 values as your validation period or any other such condition or that is defined. All right. So this is what is known as the validation period, and that is most essential. Only then we'll be able to check whether it works. Now we have certain naive forecasts. Now the good thing about forecasting is, you know what, that you can come up with any forecast model under the sky. All right, any forecast model under the sky, if it satisfies the requirement of the error. All right, if it satisfies the requirement of the error, then your forecast model or your forecast method is good. All right. Yeah, is it clear till this point of time? Sorry. I'm not able to see the messages. Okay, here they are. All right. Somebody raised a hand. Raised a hand is a okay. All right. Now, what is the meaning of this knife forecast? This first forecast is called the last sample method. Now, we all know the hat, the funda of the hat. When you put a hat, it means it is a predicted value or a forecasted value. Now, what I'm saying is somebody comes to me. All right, somebody comes to me. Who comes to me? Let us go back to this DVD sales. I know it is not relevant, but still let us go back to that particular case. Now, in this scenario, all right, somebody asks me, what can I expect to be the sale here on the 13th month? So I simply say, he gives me the data. I said, no, I don't want the data. All right, I am a very smart guy. I don't want data. You tell me what is the last sale you had. So you will say the last sale I had was 160. Okay. Next month also you'll have 160. That is my forecast. Next month also is my this thing. That is my forecast I'm saying. So what he will immediately ask is, so you mean to say that if I had come to you in the previous month, when I had finished sales of when I had starting of 12th month, you would have said that I will get 150? Yes, absolutely. I would have said that only. If you work back, that is what I mean. Meaning, this is what you're trying to say? Yes, this is what I'm trying to say. What I'm trying to say is, by the last sample method. So what at the end of the first month, before the start of the second month, what should have been the predicted value is nothing but this value, this value, this value, this value. Now, once I have these forecasts, now remember the forecast, remember these are all forecasts. Forecast is not necessarily 160. This is of course the forecast for the future, but working back in the retrospective way, this is the forecast. Now, when I were to take the difference between these values, 130 minus 123, all right, and then excuse me, 130 minus 123, 125 minus 130, 138 minus 125, I will get some errors. If those errors are less, if those errors are less than any other model's errors, then I can go ahead with this model. Do you understand the concept of any model under the sky can be a good model? Is it clear, friends? Yeah. Similarly, you may even say a k-step model. Generally, you know what? The data that somebody comes to me and says, can you do a forecast? I said, what type of data is this? What is this data all about? This data is about, something to do with uh, the number of people visiting a weekly market. All right, we have a market here, number of people visiting the weekly market. He says, you know what? People generally tend to buy vegetables every 3 days. Nobody buys vegetables every day. So someday they will buy. If somebody buys on Monday, then Tuesday, Wednesday, he will not come. He'll come on Thursday. If somebody is buying on Tuesday, then Wednesday, Thursday, he will not come. He'll come on Friday. So there's going to be a relationship between how many people come on Monday and on Wednesday, on Thursday, Tuesday and Friday, like that. There's going to be a relationship. So what you do is, if you want the forecast for tomorrow, then 2 days before the value that you have got, that is your forecast. Slightly scientific, but pretty much what you say, a thought process. Is it making sense? Is it making sense, friends? All right. So on that note, we'll take a break. Seven minutes. All right, let us continue. Now, I'll address the questions in a moment. There is also something called as the seasonal series forecast. All right. We discussed about the people visiting a hotel, right? For instance, I'm looking for a blank space, not there, so I'll probably create one. Here. All right. So I have data, daily sales data, daily restaurant footfalls data, people coming to a hotel, to a restaurant to have food for the last 30 days or 35 days. So I have 1, 2, 3, 4, 5, 6, 7, 35 days data. Now the 35th day data is Tuesday. 34th day data is Monday. 33 is Sunday. 32 is Saturday. So on and so forth. Now I have the Y1, Y2, Y3, Y35 values. All right, I have these values. Now, what is the forecast which I will get at Y35 plus 3? This value is going to be Y35 minus 7 plus 3, because the seasonality here is 7. So what is 35 minus 7? So I have data till Tuesday. So I want the value for Wednesday, Thursday, Friday, because that will be 36, 37, 38. So I want the 38th data. So I want the Friday data. So 35 minus 7 will give me the last Tuesday, plus 3 will give me the last Friday. So last Friday data is going to be the next Friday data. Is it making sense? All right. Please post the attendance. Team, please post the attendance. Yeah. So you can have the same thing in the seasonal series. Now suppose you have monthly data, all right, and the seasonality, length of seasonality or the value of M is 12, all right, the length of seasonality is 12. Then if I am today, I have data till October. I want to know what is going to be the number of people registrations for our data science training program in January. So October plus November, December, January plus 3 is going to be January. So October minus 12 plus 3 is going to be the number of people who registered January last year or January 2020. Is it clear? So you can, so the M there, the capital M is the length of seasonality. Now we were talking about the error. Now when we discussed about the last sample method, all right, and all those things, we were talking about the the errors. All right, and what do you do with the errors? Because errors are going to be many, right? Number of data points, that much number of errors are going to be there. So what do? We have to aggregate these errors to give us a single value. So an error is nothing but y minus y hat or yt minus yt hat. All right, that is nothing but the forecast error represented as et. Now if the model is adequate, forecast error should contain no information. Plots of et should resemble that of a white noise or uncorrelated random number with zero mean, blah blah blah. Let us not go into those details. There are two illustrations given below, which is very interesting. The illustration on the left shows a woman and some kind of a crash. All right, so it is a spaceship crash in the year 1986 or 88, I'm not too sure. Challenger. All right, the Challenger, again now I'm getting confused, is it Challenger or Discovery? But anyway, I think it was Challenger. Within 78 or 79 seconds of its takeoff, it totally got incinerated. It totally burned down, and even before it could leave the Earth's atmosphere, Earth's gravitational force completely, it burnt. Obviously, everybody lost their lives. This woman became pretty famous because NASA, for the first time, had invited civilians for the space launch, and she had been training for over a year. All right, she was recruited and she had no prior experience, and when they had done some kind of thing, and she was a school teacher, and then she had undergone training for a year to be one of those, civilians also should be part of that, and unfortunately she lost her life. Now when they worked out and found out what happened, it was because of some kind of sealing ring. All right, it was some kind of sealing ring that was the reason why the thing happened, meaning the fuel sealing ring, I don't know the full details of it, but the fuel sealing ring is something that expands with the temperature. All right, the fuel sealing ring expands with the temperature, and subsequently when the temperature goes down, it has to become smaller again. Now between the expansion to the contraction, if there is a difference, all right, now I'm talking about microns here. Most of you are aware we are talking about microns here. So if it is expanding and if it is contracting by not the same level and something is left over, then we can have a problem of the fuel leaking. Is it clear? Yamini, please turn off your webcam. Yamini, please turn off your webcam. Yeah. Do you understand, friends, how a small micron, few microns of error, all right, has caused an entire multi-billion, $1 million equipment to go to the sea. Now on the right hand side, you have the very famous breakfast idli. Now there is a standard size for the idli. You're supposed to make it as per some size. Now if the size is off by a few millimeters, even 1 or 2 centimeters, is it a big problem? Will it cause a big problem? Absolutely not. So in one side, an error of a few microns is so critical, and in the other side, an error of up to 7, 8, 9, 10 millimeters or even 1 centimeter, 2 centimeters also is not critical. Therefore, it depends on the error and the data itself. Is it making sense? Is it clear, friends? Yeah, is it clear? No responses? Okay. The letter yes is more than enough. You don't have to yes and all that is not required. Just the letter yes is more than enough. Now, what can we do with the error? There are many things we can do with the error. One is we can take the mean of the error, but we know that if we take the mean of the error, we have the same problem that we had where? Where we had that problem. Remember the problem we had somewhere when we took the average of the error? What was it? It was in the first few classes. We were talking about the variance, dispersion, x minus mu. If I take x minus mu and do the summation of x minus mu, the positive and negative will cancel each other, and therefore we will not be able to make the true sense of the error. So mean error can be a problem. Therefore, you can do MAD, which stands for mean absolute deviation. You can take the absolute values and then add it up. That is going to compensate or take care of the problem of the negative values, and only positive values will be there. Or you can take what is known as the MSE or mean square error, or you can do the RMSE. Now MSE, RMSE, all these things we have learnt as part of our regression modeling or as part of our predictive modeling. Yes or no? Perfect. What we have not learned, and there was also a case that I wanted to tell you. I think we were discussing about the RMSE and things like that. Sorry, the RMSE. All right, yeah, RMSE in certain models we were discussing, and I was telling you that by looking at the RMSE, we cannot really talk about the overfit, underfit, things like that. We need to have the error in percentage terms. Only if you have the error in percentage terms will we be able to talk about the overfit and underfit. Do you recall this? Yeah, we mentioned that, right? So to get the error in the percentage terms, we can do the mean percentage error. So what we are going to do is we are going to take the error and divide it by the YT. So basically YT minus YT hat divided by YT. So this is going to be the error by the value, and therefore it will become a percentage value. Now MPE, mean percentage error, has the same problem as the mean error, wherein positives and negatives will give you inconsistent or incorrect information, and therefore we may have to go for the MAPE. So mean absolute percentage error. All right. So one of the two most popular methods of error identification are RMSE and MAPE. All right, RMSE and MAPE are the two most popular thing. We'll be using this subsequently. Now, this explanation here, I think you are all quite smart now. You don't need me to tell you this. But yeah, this is the explanation of why mean error and is not a correct measurement. We think that both are actually the same error. All right, like that we have a lot of things. All right. Now, the approach to forecasting is predominantly in two ways. All right. The approach to forecasting is predominantly in two ways. One is the model driven method, and the other is the data driven method. All right. The model driven method, we are going to be building some models. There are various things like linear regression, AR model, ARIMA, logistic, econometric. So we'll be looking into a few of the model driven methods, not all. And similarly, we'll be looking into a few of the data driven methods, not all. All right. Okay. Now this is, let me now go ahead and show the data. We've already seen this data. I mean, a small snapshot of the data, not the entire data. This is the excuse me. This is the data that we have. Excuse me. So Jan 1991 to March 2004. Yeah, it was. I remember mentioning that. I don't know if it is April or March, but yeah, we have data till March 2004. So assume that we are today on 1st April 2004, and therefore we have data till yesterday, which is yesterday was the 31st March 2004, and then we need to go ahead and collect the remaining things. All right. Now, what is the first thing we'll do when we get the data? What is the first thing we'll do when we get the data? Yeah, all those things are fine, data cleansing and all that. You have to do EDA, right? You have to do EDA. So what is the first thing we can do as part of the EDA? Find the level. Absolutely right. Find the level. So this particular Walmart is operating at 1822. It is actually in thousands. So 1822 or 1,82,000, no, not 1 lakh, 18 lakhs, 20, yeah, 18 lakhs, 22,226. All right, is what the average it is operating at. All right, that is one thing. Next, what is the next thing we should do now? We should visualize this. All right, we should visualize this. And this is the time plot. Now, to give you a good perception, because you should also become a little good in Excel as well. So the minimum value is somewhere 1250. And the top value is 2250. All right. Nice visualization. You have the nice up, down, up, down, up, down. All right. Nice visualization is there. And yeah, I think we can probably go ahead with this. All right. So this is the data. We have seen it. And let me close this without saving it. Now, let me open the R code. Just give me a moment. Oh, great. 16 people have left after the attendance. Very nice. So I think about 100 people are what we have, the regulars. So I can tell my team that not more than 100 certificates will be required. Yeah. Very much required attendance. Very much required attendance. Without attendance, without 80% attendance, we will not give the certificate. That we are very, very clear. So I have the code here, very nice code here. And let us load the file. Oh, why is all this open? Let me just erase all this. Yeah. So we load this package. And read the file. It is open here. Walmart footfalls raw. I have loaded this 159 records and 2 columns. All right, we've already seen it. But nevertheless, let me show it again. So this is the data that we have. And then we need to now start doing the pre-processing. But before that, coming back to the presentation, we are proposing to do linear regression modeling for this particular data. Now for linear regression, what is it that you need? What is it that you need for linear regression? Please tell me. For linear regression, what is the, because I'm going to be using this opportunity to be doing a lot of recaps, questioning you, etc. For the purpose of linear regression, you need 2 things minimum. The 2 things are, I'm very sorry, my bad, sorry. Missed out a lot of questions. I'll get back to the questions in a moment. Is structured, unstructured? This is structured, obviously. All right. I'm sorry, attendance link is closed for today, so there's nothing much we can do. It expires, so we cannot redo the attendance. That is not possible. Yeah. All right. So we have 2 things. One is the input and the other is the output. We need 2 things to be able to build a model. But do we have the input? We have the output because it is Y. But do we have the input? Obviously not. We don't have the input. So we have to create an input. Now, if you remember, maybe I closed it too soon. I'll probably open it once again. And I'll plot it again. It's important that we understand it. There was a reason why I had paused the chat messages. All right, because it's very distracting to be reading these messages that are not at all related. Because in my experience with this batch, very rarely I get questions. Very rarely, unfortunately, I have to accept. Very rarely I get some questions that is motivating or pushing me to my limits. Most of the times it is things like attendance and certificate and things like that. That is really unfortunate. All right. I mean, the true student will be somebody who is going to attend this course and not bother about the certificate, because it is knowledge is yours. All right, that certificate is not going to, make you something really great. You should be able to answer the interview after that. The certificate may get you a chance to that interview, but you're going to utterly fail. And if you don't even have a certificate, and if you can actually show the projects, the work that you have done in your resume, I mean, I take interviews and people say, sir, you please check my GitHub. I mean, the confidence. There was a girl I interviewed today. I have done 25 projects. I will give you my GitHub link. You first see my GitHub link and then we can have the interview. That was the confidence that girl had. 1 year back, she has passed out, just 1 year. And within that, she has done 25 projects in data science. All right. She doesn't need a single certificate to prove herself. And yes, there's a good chance we'll be taking her, whatever position is there, I'll be taking her. I was going through it. Amazing work she has done. Right. You must go to that level rather than trying to, cover up your disabilities, or whatever you are not able to do under certificates. Right. That is what is expected. Anyway, let me not waste time. Okay, so what did I do? Let me do the plot. All right, let me do the plot. All right, this is what we have. Now, if you notice in the bottom, you have this, this visualization. My bad, I should have done that. Yeah. Now this visualization, if I do it like this, all right, if I do it like this and then I format the axis to 1340, all right, when I put it like this, now what do I have here? I have the values here, the Jan, Feb, March, April, May, June, like that. So basically like this it is going, whatever it is going. All right, that is fine. Now what I can do is I can treat this first value as 1. I think Jan 91 or something. I can treat the first value as 1. I can treat the second value as 2. I can treat the third value as 3, so on and so forth. All right. And what will I get when I do that? I will get an input. All right. I will get an input. With that, and that is going to help me with the modeling. So I'm going to create a column T, add it to Walmart and add values 1 to 159. So when I execute that, my Walmart data becomes 3 columns. When you view it, you have this month, footfalls, and T. All right. Then we've already built polynomial models in the past. Yes, we have built polynomial models in the past. So what do we need? The input squared. So I'm going to take T squared just to check if there is any relationship between them. Is it clear? So I'm going to take another variable called T square, which is going to be the multiplication of the T into T. So when I run this, I have 4 columns in my object, which is Walmart. All right. Now, once I have done the T square, I can also do the log, because remember we had done the exponential model. All right, we had done the exponential model also. So I'm going to run that also. All right. So this is what we have done so far. All right. With this, I have got these. So not only have I got 2 inputs, but I've also taken the variant of the output itself, because I may want to build a polynomial model or a exponential model. All right, fine. Now coming back to the data here, all right, coming back to the data here, I want to know if this 1709 and if this 1615 and if this 1705, are they having some relationship? Do you understand what I'm trying to say here, friends? Is 1709, 1615 and 1705 related to each other? All right. Which means I want to find out if 1621 and 1557 and 1619 are related to each other. Maragadam, please turn off your webcam. Maragadam, please turn off your webcam. See, many of you attend the session using your mobile phones. It's okay, perfectly all right. But please don't walk around with your mobile phone, holding your mobile phone. Put it on some kind of a stand. Don't touch it. This is a common problem. You will either turn off your webcam or you will turn off your audio, and you will not realize and you'll be talking. All right. So it's okay to attend, but you should probably, it's okay. I mean, it was a genuine mistake. I understand that. All right. No problem. All right. So what I'm trying to do here is I'm trying to establish a relationship with the values in conjunction to the month in which they are from. All right. All right. So therefore, I want to find out if all these values are similar. So I'm going to create something called as a dummy variable. So I'm going to create Jan, Feb, and I'm going to go all the way to December. I think I can delete this. So if this is a January month data, then this is what it means. This is what it means. If this is February month data, then this is what it means. So when I build a model with these values as input, I'll be able to tell the relationship between Jan to Jan, Feb to Feb, March to March, April to April, May to May, so on and so forth. Is it making sense? Do you understand the concept here? So that is what we are now going to do in our code by creating that particular aspect of the dummy variable. So I'm going to create an object called X. All right. I'm going to create an object called X in which I am going to put the month.abb. Month.abb, if you look at it, it is nothing but Jan, Feb, March. I'm going to do the repetition of month.abb 159 times. All right. And then I'm going to put it in such a way in the data frame that I'm going to give all values 0 except where the month.abb corresponding value is there. So when I do this, now if you look at this at the X, you have the values 0, 1, 1, 1, diagonally it is going down. All right. So now I'm going to assign column names to this particular table. All right. I'm going to assign column names to this particular table, which has got month.abb. So when I execute this and when I view this, this is what I have. Is it clear? Great. So now this particular object X, I'm going to combine it with Walmart. All right. Walmart already has 5 columns. So we do this. Now if you look at the column names of Walmart, month, footfalls, T square, log of footfalls, Jan, Feb, March, April, May, all the way to December. If you want to view it, this is what it looks like. Amazing. All right. Now let me go a few slides back, not a few slides back, many slides back here. I hope you have all understood what pre-processing the data means. Yes, I hope you all understood what pre-processing the data means. That is what we have been doing till now. All right. This is pre-processing the data. Now, once we have pre-processed the data, we have to partition it. All right. So we'll partition it also. So let us go back here. All right. Now I'm going to attach the Walmart data. All right. And split the data into train and test. Now 159 records Obviously, remember I told you it has to be done in series. All right. And when you do this, you have 157 records in the train. And then when you do that, you have 12 records in the test. 12 rows, the last 12 rows. So we have also learned about partitioning and how to partition. Then you apply forecasting methods. Now, what was the thing that we learned? What was the thing that we learned when we were doing regression? What was, remember when we are doing simple linear regression, I told you there's a limitation to the regression model. What was it? Don't remember? I told you, do I have a blank sheet? 1 minute. Somewhere I put a blank sheet. It's okay. Let me just look for it. Yeah, this one I can use. If you remember when we were doing regression, X and Y, no, whether it is simple or multiple, there is a limitation to that. So if I have data like this, all right, if I have data like this, then so this is your X min and this is your X max. Is it clear? X min and X max. Is it clear? My model that I build works only for y is equal to beta naught plus beta 1x, where x can take the values from x min to x max. Do you understand? My x, the input, the future values, whatever I'm going to take, my model is only going to work for the limits for which my model was originally defined. Now, if I'm going to have if I'm going to have, let us say, multilinear regression, where I'm going to have multiple inputs, each of those inputs will have a max and min value. And for those max min values alone, between those values, I can build the model. But what we are going to do in forecasting is we are going to change this rule. We are going to simply take this rule and this condition and put it in the dustbin. We are going to actually extrapolate. All right. Now, if you look at this, what is my model? My model is like this, which means my model is in linear regression terms, my model is intrapolative, meaning from this portion to this portion, I can use it. I cannot extrapolate on this and say, okay, what will happen for this or what will happen for this? It is not possible. But in forecasting, I am using regression for extrapolating. Is it clear? So now I'm going to build a model with footfalls as the output, T as the input, and trying to see if I can get some thing. So when I run the model with the train data, and when I look at the summary, if you look at the summary, 9%, very, very low. The p values are all right, but this is very, very low, the R square. But I am not interested in all these things. I am least bothered about all these things. Why? Because I'm not using linear regression like a linear regression within the values. My objective, what is my t value for this particular train data? What is my t value? My t value is 147. I am going to use this for t is equal to 148, 149, 150, 151. So therefore, it doesn't matter what these information is. I am only interested in the error. So now that I have built this model, what I'm going to do is I'm going to predict using this model, using the prediction interval for the new data test, which is beyond my train data. So when I run this, I'll get some prediction values. All right, these are the prediction values for 148 all the way to 159. And then we are going to find the difference, take the square, take the mean, take the square root. All right. Na.rm is equal to true simply stands for if there is an Na value, then do not include them. All right. So that is what it is. Then I do this and I run the RMSE. The RMSE is equal to 209, meaning so much error. Now, what is 209? How do I interpret 209? I really cannot do that. I have to only interpret it in the perspective of other models. Therefore, we are going to build more models to make sense of it. All right, make sense of it. Is it clear? Any questions till this point of time? Because I propose to do the remaining models in the next class. I know it is still 5 minutes are left, but I have 4 minutes are left. But today is actually Karwa Chauth. Some of you may be aware, you must have watched Hindi movies. So my wife is observing fast without water. Yeah, some of you may be aware, some of you may not be aware, but if you watched some Hindi movies, Karwa Chauth. So that is why I like to leave a few minutes early. So any questions, I'll address them, not a problem. Yes, you have a question? Okay. All right. Thank you so much. Can the data be manipulated? In what sense? See, we have not manipulated any of the data. This data has not been manipulated, the original data. We are doing some mathematical values to the other things. We are taking the log of it, but we are not changing this data. We can take the log of this value, exponential of this value, etc. we can do, but we are not essentially changing this data. Manipulation means you are trying to do some fraud like thing. That is what the word manipulation essentially is. We are not doing that. Is it clear? Thank you. Thank you for your wishes. All right, then we'll stop here and continue the next class. Thank you so much. Have a great day. Bye. Yeah, team, stop live.